Hey, I'm Mr. Bahork, and today we're looking at parallel and perpendicular lines. It's been a little while since I put up a new video. I got a new laptop and trying out some new recording software, seeing how it works. I don't know. We'll see how this goes. Right now, the cursor you might be able to see is blinking at me like furiously, and it's kind of gives me a headache. But I'm gonna do some math anyway because I love it so much. So let's start off by graphing just a normal old y equals, let's say, 1/2 x plus 1. Let's graph that line. And I'll graph it on this graph. So our y-intercept is 1. And we're going to go up 1 over 2. That's a rise of 1, run of 2. I'll do that a couple times so I could at least try to make my line look kind of straight. It's really hard to do with this tablet thing, but I'll do what I can. I'm used to like turning the paper. That's not that bad. It's better than my other attempts. So it's the best I can do. So let's go ahead and try to graph a line that's just slightly different, but you know what? I'm going to keep the slope the same. So y equals 1/2 x plus 3. We'll see what happens here. I'm going to go up to 3 for my y-intercept. I'm going to go up 1 over 2. Up 1 over 2. I'm going to keep going up 1 over 2. So just to make my line straight, I'll do another one. So I'll draw my line. You might notice something interesting about these two lines. And I'm going to draw a third one just because I feel like it. So how about y equals 1/2 x, keep the slope the same, minus 4. Y-intercept of negative 4, so up 1 over 2, up 1 over 2, blah, 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 blah. Okay, sound like a broken record, but there's my other line. So you probably have noticed something here. All of these lines are what we would normally call parallel. They're all parallel. And if you'll notice, the equation of each of these lines that ended up being parallel, they all share something in common. They all have the same slope. So parallel lines, they have the same slope. So if I want to know if two lines are parallel, I'm checking their slopes. So I don't even have to graph it. If I said y equals 3x minus 2, and then I said y equals 3x minus 10, those are parallel. I don't even have to graph it. I know right away because their slopes are identical. And when I say identical, I mean identical. One can't be negative and the other positive. They got to be the same thing exactly. So that's it. That's basically parallel lines in a nutshell. Okay, the slopes have to be identical. So what's all the hubbubaloo about perpendicular lines? So what in the world would that look like? So let me go ahead and change this back. And let's look at two different lines. Let's say I want to graph y equals 2x minus, I don't know, how about 3? And then I got y equals negative 1/2 x. Let's say plus 2. Sounds good to me. Y-intercepts don't matter here. You'll see why. So I need a graph, alakazam. And let's begin graphing these. The first one I'm going to graph in red. So I'm going to graph that guy in red. So I'm going to go down 3. There's my point. And I'm going to go up 2 over 1. So up 2 over 1. Up 2 over 1. I'm going to try to make this really straight so you can really see when I graph this, you can really see the perpendicularness of the line. So let's see what I can do here. Oh, that's not that good, but I hope this will work. All right, so there's my pretty awful line for the first one. So let's try to do another one. Let's do, I'll do this one in blue, okay, just like the color I wrote it in. Whoa, I don't know what happened there. Okay, I'll do this one in blue. So we're going to go y-intercept of 2 right there, and we're going to go down 1 over 2. Down 1 over 2, etc., and there's going to be my nice pretty line. That's pretty good. I kind of messed up over here. Anyways, so you can see it makes that nice 90-degree angle that a perpendicular line is supposed to have, and it's a little bit sloppy, but it does do that. So what was the difference here? What happened with these? Well, it's all about the slopes. Okay, the slopes are actually special for perpendicular lines, and so for perpendicular lines, and that's the symbol for perpendicular if I can actually draw it straight. It's like that. It's kind of like a little two L's back to back. They're hanging out. So perpendicular lines, they have opposite reciprocal slopes. So what does that mean? Let's say I have a slope of 3. And I wanted a perpendicular slope to that. So what I want to do is I want to turn 3 into its opposite. So that's negative 3. So you draw the opposite, negative 3. It's the opposite. Okay, and then I want to make it its reciprocal. So I want the reciprocal of negative 3. If you remember reciprocal, it's a number I multiply negative 3 by to get, or a number, yeah, multiply negative 3 by to get a 1. So that would be negative 1/3. If you don't remember, the easy way to remember it is you kind of flip negative 3 upside down. So this is like a negative 3 over 1. So it gets flipped upside down to 1 over negative 3. So that would be the opposite reciprocal of 3. So let's do another one. Okay. So let's say I had I don't know, how about negative 4/3? So I want the opposite reciprocal. I want a perpendicular slope, so opposite reciprocal. So the opposite of 4/3 or negative 4/3 would be positive 4/3, and then reciprocal. So kind of think about flipping it. So positive 3/4, and that would be a perpendicular slope. All right, I'm Mr. Bork, and that was parallel and perpendicular lines.